All right, I'm back. We are on page 255. We're at the top. We're going to talk about approximating limits numerically, which is kind of a big deal. We'll talk about that a lot more later on. But for now, what we want to do is we want to take a look at this. So this is a weird looking function. We want to investigate the limit as x approaches 12 of the square root of x minus 3 over x minus 12. So what is going on? There's like a certain structure to this that looks weird. Like we got 12 here is our limit, but then this is 12. And then if I took 12 and I plugged it into radical x minus 3, I would get radical 9, and radical 9 is 3. So there's something going on here. There's like a lot of interrelated things. And what's happening is that actually, bear with me for a second, if f of x is the square root of x minus 3, then one possible point that's on that curve would be 12, 3, right? That's a point. Plug in 12, square root of 9, square root of 9 is 3, so that works. Another really weird point is the point x comma square root of x minus 3. And this is a really common thing to do, where you write a very generic ordered pair. Once I've done that, if I find the slope between those, it would be the change in y, which is radical x minus 3, over the change in x, which would be x minus 12. This is a slope formula. It's also a difference quotient. It's actually the difference quotient. Kind of like there are a lot of unit circles, but there's the unit circle. There's a lot of difference quotients. This is the difference quotient, like f of b minus, well, yeah, it's the difference quotient. So this, I'm going to say, why am I moving? This is slope. So what are we doing? Well, if I graph this, so it's going to start at 3, go this way. So let's say that this is 12, right? Okay, so we got 2 points. We have 1 point that's at 12, 3. So the reason I did 3 is on the x-axis, the domain of this function is x is greater than or equal to 3. It's just radical x, but shifted 3 units to the right. So we have 1 point. Let's use a different color. We have our point here at 12, 3. And then we have some other point that's on this. So I'm going to put it here. And what we're finding is the slope between them. So we're finding kind of, oh God, the slope of that line. But since we're going to take the limit as x approaches 12, so this is our point x, f of x. As x gets closer to 12, let's do a different one. As x gets closer to 12, our line is going to change. And then let's do another one. So when I get here, my line's going to be like that. I'm trying to find exactly the slope of this curve at exactly x equals 12. Foundational idea in calculus is, what is the slope of a curve at a point? We've already seen on a linear function, the slope is the same everywhere. It's just the slope of the line. But what if it's not linear? What if the slope changes? I mean, if you were walking along this curve, you would recognize that initially starting at x equals 3, it's like pretty steep. But as you go up, it gets less steep. So like the slope is changing. We're trying to find the slope at exactly x equals 12. So that's a lot, because all we're supposed to do is use our calculator to do this. So let's do that. So I'm going to share a calculator page. All right, and I'm going to define a function, f of x, and I'm going to call it square root, well, I'm not going to call it anything, square root of x minus 3 over x minus 12. Okay, so I need to be within 0.001 of 12. So if I do f of 12 minus 0.001, I get 0.166671. Let's do f of 12 plus 0.001. So we're like really close. So like this is how we can numerically estimate a limit. Just get incredibly close to the value. I get 0.1666, I don't know, 4 sixes and a 2. That's like really close. So I'm going to say in my notes that the range of possible values for the limit, so I'm going to say that L, and I'll show the notes in a second, is in between the, so it's, which one of those is smaller? 0.16, why is that one smaller than the other? Oh yeah, I'm like confusing myself. It makes sense. So 0.1666, oh my God, 6, okay, so I'm gonna go with 3 sixes. I'm gonna go with 4 sixes so that I like get different things, and then 0.1667. So it's in between those. So now why is it that 12 plus 0.001 gave us a smaller value than 12 minus 0.001? Let's go back to the notes and take a look at that really briefly. There's nothing I do is brief, but you know, I'm saying it. You can make it brief by speeding it up. Look at this curve, right? So we're approximating the slope between 2 points. In fact, let me redraw it up here, and I'm gonna draw it a little more extreme. So, you know, this. We're approximating the slope between 2 points. So this is the point we're interested in. And then we did 2 points, one to the left and one to the right. So here, if I find the slope through those 2 points, it's going to be like pretty steep, right? And then there's another one here. I need to find the slope between the red point and the blue point. I don't know if I'm illustrating my point here because I'm not a good enough artist, but it makes sense to me that when the point is to the right of 12, the slope will be less because as you walk up the curve, it gets less steep. So it made sense that when we did 12 minus 0.001, we got a bigger slope than when we did 12 plus 0.001. These are the kinds of things you want to think about. Like, why did those values come out the way they did? I wrote my inequality. Do we think that it's reasonable to say that there's a limit? I feel like it's pretty reasonable. And actually, if I need to do it to 3 decimal places, I feel pretty confident in saying that the limit as x approaches 12 of the square root of x minus 3 minus 12 over x minus 12. That's wrong. Hold on. I said, do you know what? In my mind, I'm like replaying it right now. I feel like I said x minus 3. Oh no, I said x. Yeah, I'm wrong. Okay, this is a 3. That's a 3. You knew it. I maybe knew it. I don't know. I'm content to say that this is 0.167 to 3 decimal places, which I think is probably 1/6. And what I'm going to do is, I feel like this may have run longer than I intended. It'll probably be a shorter video, but longer on this one question than I intended. So what I'm going to do, go back to the calculator, see what the limit is. I'm just going to ask, and then I'll shut this down for a second. So let's do the limit. Let's do the limit as x approaches, as x goes to 12 of f of x. 1/6. It's exactly what we thought it would be, because this happens to have a nice limit. If it didn't have a nice limit, the calculator might just spit out a decimal. It could spit out a radical. It could do anything. I mean, the calculator knows what it's doing as long as you know what to ask it. So I am going to stop these here, and I will be back in the next video to keep going. So hope you are finding this helpful.